Hello, I'm Devin Harrison, and I'm just going to show you my project, or sorry, my assignment. I'm just going to do all the easy statuses because, well, they're easy. I know that they work. So there's BFS. Don't really have it actually say breadth first search. BFS just keeps going because it's essentially evaluating one path, and it's pretty much just making the whole graph down that one path. I believe that's how it's working. So I have to stop that. Won't try iterative deepening because it's pretty much the same as a depth first search. This is uniform cost, just much cheaper. Okay. That's for a search. It gives you my solution. They all look kind of different because the ordering is just a little different. Had to modify my successor functions and the way how I look for my win condition for each of them. A star looks like I can only really get the Manhattan heuristic to show up. That seems to only work, but just not for medium or hard. I think the reason why the first heuristic doesn't work is because it essentially turns into like a depth first search, and it just keeps looking for a like one path, and it just continues down it until it finds something, because all the nodes that are popped back out of my control structure pretty much looks for a min, and if they're all the same cost, it's just going to grab one at random, and that random one can just be so far away from the goal. So it's not really discriminate towards which one is actually more correct than the other. It's just more concerned with the cost. And so that was just my main concern, really, especially when it comes to everything, or when it comes to also best first search and uniform cost. Because when I get to a higher when I get to the higher difficulties, it just seems to have trouble with finding my solution, and I'm just not sure if my heuristic is correct. I sent emails and all that stuff, so at this point I'll just pretty much just show you how everything's done. So in best first search, it's pretty much just your standard best first search. Use the queue, have a list node of history. I pop the node off my parent off the queue, I make it. I pretty much, all these are just objects. I pass in the node for each of these. I make the node in the main loop in my main program, and I pretty much just use a case statement after reading user input to then run all these objects. So right back to best first search, I have to queue, list of nodes for history, pop it off, push it onto the list of nodes for my history, and right after my successor function, which pretty much all my successor function does is it takes in the node, grabs the state, and then spits out up to 4 children, because I know it could be up to 4 children depending on if the circle or if the empty space is in the center. And it basically checks all the children, including the parent, to make sure that it's not already been evaluated or popped off the stack. And so I pretty much do that for every single one. At least I try to do some version of that. And so all I do is pretty much check all the children if they are valid or not null, and then just add them to the stack and just pretty much evaluate them. And then as you can see, there's my bookkeeping. And so that's how I check my children. And that's my testing. And so for DFS, it's just pretty much the same thing, except it is a stack, and I pop and push instead of poll. And then iterative deepening just has a main loop right here, and then when I actually call it in my main program, I just run a loop around that program. I just run a loop around the object, calling iterative deepening, and just put a limit around that. And then uniform cost, right? This is my main loop for that. All I'm using is settled nodes, unsettled nodes. There's my bookkeeping. Every time I pop one off, every time I get a root, or every time I get a node, I pop it off my collection, and then I just add it to the unsettled nodes. And once I evaluate it, then I add it to settled nodes. And then, as you can see, there's all my bookkeeping. And then at the end, I match the goal. I say match goal uniform cost, just because it's just the ordering has to be a little bit different, and just the way how I do things is a little bit different. I think I just don't use a loop to check this, because I think my solution should just be there. And so that's just how I search for it. And so then there's best first search, his main loop here. Pretty much like my successor function is just all like the same for all of them, but it's just sometimes like the ordering is just a little bit different, and how I have to kind of search and look for my result and also print. And so that's pretty much just the difference with everything. I was just a little bit upset about A star because it didn't really work for the higher difficulties. I'm not really sure why, really. I just know that for the first heuristic it doesn't really work, because it's essentially working like a depth first search, because it's just indiscriminate towards the cost rather than if it's actually correct. And so as you see here, I have a cost comparator just for this is just all of my things. Let me just try to show this all to you, because I know I don't have a lot of time. Node list for sorting for A star. There's my state class. All this written from the ground up. Had a great time doing this. This is my pretty